So welcome everyone. We are starting our meetup. Welcome to Amsterdam. I hope you are enjoying the view. It's not the same that being here, but at least you have some feelings. So you have a QR in the screen that you can use to join our Slack. You can ask questions there, and you can also stay. Just a second, because
Nico, you have an echo.
Yeah, wait. Sorry, I have the TV playing YouTube to check that everything is okay, and it was I forgot to mute it. So a few comments about today. So first, I'm going to introduce myself. I'm Nico. I'm one of the organizers of Python Amsterdam. I have my EuroPython T-shirt here with our logo. And Jan, you can introduce yourself probably.
Yes. Wait a second.
Yeah, we are listening, right? So you can.
Okay. Yeah, I opened the YouTube tab and I heard your introduction twice. So hi everybody, I am Jan. I'm co-founder of Py.Amsterdam. We used to be organizing meetups live, but since everything happened, so we switched to this online version. We hope to organize it as often as possible. You can visit our website at py.amsterdam. When you get there, you can find a lot of useful information about us. And most importantly, at the bottom, there is a contact form for you to submit a talk. So the next time, it will be you who is talking, not just me or Nico. So for today.
So I'm going to share, let me share my screen because I have the schedule for today. Just a comment, something that I wanted to say before the schedule is that the plan we're using, in the last year, we were using Zoom for the meetups. We are testing this something different to try to improve it a bit. So we don't have the the chat, so you can use the YouTube chat, and we are going to see what's happening there. We can also, if someone is asking for a question, we can do what I'm doing right now, so you can see what someone was writing in YouTube in the screen. So please use that. So for example, here Andres is asking if someone was talking. No, we were just showing a picture. So, and then the plan for today is, okay, we have this short intro. After that, we are going to start with Darny or Daniel Moisset, that he is going to be talking about pattern matching. That is a new, fresh, shiny feature on Python 3.10. And I think it's super nice that we can have someone talking and explaining how it works. And then we are going to have Juhis that is going to be talking about contemporary documentation. And after that, we are going to do lightning talks. So first, one comment. This time is probably not exactly how much time it is going to take for the talk. So maybe the talks will take half an hour, maybe a bit more, a bit less. After each talk, we are going to have time for questions. And then for the lightning talks, because we need the person to be a speaker to join a platform that we are using. The only way, if you want to propose a lightning talk, is that you have to join our Slack, and there is a thread there that you can say, you can propose a title, and then we will contact you with a link when it's the time. And I hope we have some proposals. Lightning talks are my favorite part of a meetup. We have been doing this a lot, and if for some weird reason you don't know what's a lightning talk, that's a 5 minutes talk about anything you want to talk about, right? So you want to talk about Python, about Java, about, I don't know, swords, or about the pandemic, that's okay. Good for you, you have 5 minutes to talk about that. Good for us. If we don't like it, it's only 5 minutes. So, and as Jan said, this is our website, right? If you scroll all the way down,
I'm afraid we cannot see your screen, actually.
Oh, sorry. Wait, give me a second. It works now?
Yes.
So I was talking the whole time and there was no screen? Probably. Okay, so give me a second because I'm trying to test here. Can someone confirm in the chat that my screen is okay now, that you can see it? There's some delay with YouTube, so let's wait for that. I was saying that if you scroll all the way down, so Python Amsterdam, you go to our website, and then you scroll, you have all the links that you need to follow us. This YouTube channel, please subscribe to it, because I think if we reach some numbers, we can have some new features. There is our Slack is there. Oh, perfect. So thank you, Daniel. We have someone saying, yeah, the screen is okay now. Thank you. Sorry. So you have our meetup.com website, you have our Twitter, our email, YouTube, etc. Our Slack is also there, so if you're interested, please go there. So I think it's already 10 minutes after 7. Jan, anything else we have to say? Otherwise, I'm going to introduce Darnie.
No, I think you've covered just about everything.
Cool. So let's say welcome to Darnie.
Hi.
Hello, Daniel.
Hello.
I'm super happy to have someone from Python Argentina in this meetup. I'm originally from Argentina. That's my original community. So and I already saw some friends from there saying hello. So yeah, welcome.
Thank you. Thank you. It's nice to be here.
Yeah. So I think we are going to leave the stage for you. Are you sharing screen right now?
No, I can,
okay.
I can do it. Can you remind me how to do
it?
Oh,
so we're going to give time for Darnie to share, but I want to say that he's one of the authors of the PEP for the pattern matching. So I think it's super. I think we are going to learn a lot today. So let me turn off this. I'm going to turn on your screen. Cool.
Fantastic.
So the stage is all for you. I'm going to be in the backstage, and good luck.
Okay, thank you so much. Okay, let's get started, and welcome, and thanks for joining me here in Amsterdam or my Titan, depending on how do you want to see it. So as Nico mentioned, we will be discussing pattern matching in Python. This is a very fresh new feature in Python, so new that actually it's only in alpha releases. It hasn't been released, but it's going to be available in Python 3.10 in October. So before that, let me introduce myself a little bit. My name is Daniel Moisset. I'm originally from Argentina, but I'm living in London for the last 5 years. But yeah, I would love to actually be there. I've traveled a few times to Amsterdam. It's really nice. And I'm also one of the co-authors of the pattern matching, what we call it the PEP trilogy, because it's 3 different PEPs. Pattern matching started, there have been many discussions about this idea over time in the Python mailing lists. And in mid last year, I think it was May or June, some momentum started getting gathered again. And there was an initial PEP author, which was PEP 622, that we co-author with 4 or 5 people, including a guy called Guido van Rossum, which you may have heard of him. He's Dutch. There's a huge momentum in the community, and a lot of people doing really hard work for this. So I joined this group of people. This original PEP received a lot of feedback, so it required to do a lot of changes before getting to a stage that it can be actually approved. And something that we noticed is that when everything was in a single PEP, the feature is a pretty large change in the language. I mean, it's it introduces a lot of new concepts. So when presenting this, many people weren't sure to do with the PEP because it was hard to understand, and it was trying to do many things at the same time. It was a bit of a specification, a bit of an explanation. So we separated into 3 different PEPs. So you have PEP 6.4, which is the hard specification for language implementers. 6.35 explains why it's designed the way it is. And 6.36 is the tutorial. It's an educational document to explain it for new people that have never used it before, so people understand how it works in a general idea, not the detailed implementation. So, as I mentioned, this is something that's available right now if you're willing to download a Python alpha version, and in October you should be able to have it. So if we actually, let me open this, you should see my terminal at this point. If I run Python 3.10, you can see that I can actually enter this, which doesn't look like usual Python code. And this actually does something rather than a syntax error, which was what happened in 3.10 alpha 5. So it's out, it's working. So if you want to play with it, you can just run it and try out the examples. So let's So let's take a bit of a look at what are the ideas behind the pattern matching. And pattern matching, some people may have heard about the first thing that is out when people hear pattern. Oh, it's like regular expressions and matching strings. And the term pattern matching has been used for strings, but in our case is what we call structural pattern matching. And we're talking about the structure of objects. And pattern matching is used to work with objects that are similar but not quite. So the first question that we may ask ourselves is what makes objects different? And we can think about all the tiny little things in my background here as small objects. And I could tell you, okay, which ones are the circles? Say, okay, you have this black circle over here and this one over here, but you also have this white circle over here, and the color doesn't matter, they're all circles. And you can say, okay, what are the white figures? And you say, okay, we have this white circle, but not this black circle, this white dot, and this white plus sign, and this very white, this very big white X are all white shapes. So we are trying to have different criteria to select or separate these different shapes in my screen. And we want to do something similar with objects. So we and this is actually a term we use in the design of pattern matching. We are trying to look at the shapes of objects. So we'll use the word shape quite liberally here, not like geometrical shape like we did later in this slide, but we'll see what the shape of an object is. So this is the problem we're dealing with. We want to recognize objects, different Python objects by their shape, and we want to make the user able to write code that does different things depending on the shape of the object. So if let me see if I can see the chat. So, so the shape of an object is something that makes this object distinct to other ones, and you can think of any kind of Python objects. So if this works for me, and I know we have some lag, but I want to try this, can you type in the audience what kind of characteristics of an object you think are part of its shape? I'll wait a few seconds so I get a couple of messages in. Okay. People are telling me the lag is like 10 seconds, so bear with me while we wait. I hope someone is typing anything. Okay, so something are coming in. So someone is telling me about the dunder wrapper of an object. Yeah, well, that's something how you convert it to string. So people say concave, convex. That's more geometrical, and we're talking about data objects. So in that case, that doesn't apply. So people are saying it's attributes. That's a great answer. The size, their attributes, the methods. All of these are things that we can look at in an object. So we can look at the type of an object. Type is an essential. And yes, someone's just saying this, and was saying this 10 seconds ago. So the type of an object is an essential part. That you can recognize integers from strings are quite different, and the main difference, or the main thing that you see about the difference is that they have a different type. You can also have, for example, if you have sequences like lists or tuples, different lengths, we can consider like different shapes. If we have a mapping like a dictionary, which keys are present and which keys are missing. If we have an instance of any kind of object, which are the attributes that are there or not. So you see that many different things can be considered a shape. And even I may want to match things by more exact values. So for example, when I want to select, I want to say, you know what, I'm interested in the white circle that's on the right side of my slide, and it's this one over here. And it's just as one, so I can match by exact value too. And to make it more complicated, when matching objects, I can start nesting these and combining one with the other. So this essentially provides me a way of, given an object that can take several shapes, I can figure out what think of shapes fitting holes, what hole this shape fits, and based on all of these criteria. The first thing that you may think when I'm saying this is, oh, this is like a Boolean condition. This is like a predicate or something, a function that returns true and false on a given object. And this is the first confusion that people get when about pattern matching the way we presented it, is that, oh, it's a way of making nice if statements with nicer Boolean expressions. But there's an important insight that comes and that goes beyond saying if an object has a given shape or not, which is the Boolean yes/no answer that we're asking. But an important thing is that when we're writing code that cares about the shape of the objects, normally our code cares about the shape of the objects because we want to do something else with the object that depends on the shape. And typically what we want to do is to pull out some information from inside the object. So this is the key insight in pattern matching. When you're checking the shape of an object, what you want to do later on is extract data from it. So if you're checking if X is an instance of some type called DAC, it's because you probably want to call some DAC method on top of X. When you're checking on the length of an X, which is supposed to be a list, and you check that it has at least 2 elements, it's probably because you want to access to 2 of those elements. If you're checking that a key is in a dictionary, you want to access that key. If you're checking that an object has a certain attribute, it's because you want to access that attribute. So for many of these things, you have a condition, which is the Boolean expression on the left, but you also have some data extraction operation, which is the one in bold on the right, which is associated to that condition. Otherwise, you want to do both things at the same time. And the idea of pattern matching is combining these these two concepts into a single thing. So the key component of pattern matching will be our patterns. And the pattern will describe not just the shape of an object, but what kind of data inside the object we want to extract, what part of the object we are interested in. And we actually have something like that in Python, because we say, okay, we're designing patterns and we need some syntax where we can pull an object apart and get the little pieces and put them inside variables. And if you've ever used this syntax for this is called tuple unpacking, and I'm using the more advanced one where you can, for example, use this star in the middle to unpack multiple elements, you can essentially take apart a sequence, or actually any iterable in this case. And what we're telling here is put the first element into A, the last element into C, and everything in the middle into B with this assignment over here. So this feature is already there in older versions of Python, and it's very similar to what we want to achieve in pattern matching. And we're trying to we design pattern matching to follow many of these ideas. In many ways, pattern matching is taking this idea and cranking it up to 11 to max power, and see how far we can get with that. So as you can see, when I'm doing this, this is checking that the right-hand side is some sort of sequence of at least 2 elements. If I get a sequence that's too short, I'll get some sort of type error when running this code. So I have the conditional checking there. But this will also assign to some variables. And if you look at this, this is this syntax on the left. It looks like you can use this syntax A star B and C on the left assignment. You can also use it on the right, or when passing parameters to a function or an int statement. But when it's on the left on the assignment, it has a different meaning, because on the left on the assignment, it's describing how to decompose a structure. Well, if you put it, if you put this in, for example, a print statement, and A is 1, B is a list with 3, 5, 7, and C is 9, you'll get this list back together. So you get the original list by using something like the assignment target that we used before. And this is something that's, that we'll find in the syntax of pattern matching. We're describing some object decomposition, but the object decomposition, it mimics or it mirrors the way we build a new object. So this code here is building a new object, building a new list. But this A star B C is not building a new list. It's actually unbuilding a list. So again, this is an idea which is already present in list unpacking, and we'll try to follow the same idea with pattern matching. So what we'd like to do is we will have these patterns on the left. And the question we are trying to ask is if the pattern of the left can generate the object on the right. We will call this object subject, and this is the terminology we use when pattern matching. We are matching a pattern with a subject and seeing if they fit each other. So the subject is my color piece, so like a particular plus sign, black plus sign on my right-hand side. And the pattern is a certain rule, like saying all black objects. And essentially, the way we describe the pattern in Python is some bit of code, and we see if we can generate the code right. So the number 1 can generate the value 1 directly. That's what it does. So there's a match here. The value x can generate the value true. The thing that needs to happen for this generator to be successful is that x should be true. So in this case, matching this pattern with this subject will actually set x to true to make these two sides match each other. Can x match with a list like this? Yes, if x is set to the list 1, 2, 3, this will be a successful match. However, in this case, if you have a list of 2 elements x and y match, there's no value that I can set to x and y that make these things equal to each other. So in this case, the pattern of the left will not match the subject on the right. And you can match if the elements align, and the type doesn't matter, of course, because this is regular Python. X will get assigned to foo, and Y will get assigned to 42 if I match these to each other. I get a successful match with two name bindings, X is assigned to foo and Y to 42. And again, something like this is a valid pattern and can generate integer numbers, but it will never generate a number like this. So there's no value of X which will make int of X equal to 3.0. So that's what I'm saying here. It's not like the hard rule, but it's an intuitive context. So if you use it as a hard rule, you'll find that there are some exceptions. So again, at that point, you can look at the spec, but to get a general idea of how pattern matching works, this idea of looking at the pattern and see if it can generate the subject is a very good first approach. So let's look at what some patterns look like. And essentially, for each pattern on the left column over here, there will be a condition that must be satisfied for the pattern to match, which is described here in the middle, and I describe in Python most of the time. And there's also some data extraction that the pattern may end up doing, which is described on the right, or in many cases there's no extraction done at all. So if I use something like a number or a string as a pattern, essentially that matches if the object which is subject, which I have over here, is equal to the constant value, the literal value that I'm using here. This one on top is called a literal pattern. And for some special values like true, false, and none, and that's the whole list, comparison is done using the is operator rather than equality, because that's the proper way to compare these, the one that makes more sense. So these patterns are very simple. There's essentially some sort of equality comparison with no data structure extraction. And you can even use, rather than specific literals, some constants like this. But we will go back to this one in a second. Oh, what happened there? Sorry, my monitor turned off and on. I hope. Oh, sorry about that. My laptop is complaining about lack of power. I thought it was plugged in.
Sorry, I was on mute. So we lost Danny. He was trying to fix the power of the computer. So I think, I don't know, Yanni, if you are there, but I think it's time for some pie jokes or something like that, just to kill the to kill some time. I want to say as a reminder that we are going to have some lightning talks today. That if you want to present a lightning talk, you can do that in our Slack. If you want to join our Slack, you can use this QR that is here. So you can just scan it and join. And there is a thread there that you can use to propose a lightning talk. So Jan, I'm going to turn your camera on. Welcome.
Hello. So
Danny was trying to fix some power issues. I think his computer went off. So we're going to improvise for a few minutes, and we are going to be back later. If anyone has a question, this is the time to do it.
So it's pie jokes time. So I don't know if anyone of you ever heard about pie jokes. So it's jokes as a service. It's also a Python module. So you can create automated joke bots. You can find all info here at PyJokes, PyJoke.es. and you can also install it. And once you install it, I hope I'm on a new laptop, so I'm not sure I installed it already. No, so let's install it. So what you do, hit X, install Python.
I can see that Darren is back. You have power now.
Yes.
And then
yes,
when you
I set up my
Python,
laptop very quickly, and
that's okay.
when you
That's
type
okay.
Python,
until I set
you
up
get
my
cheating jokes. So I thought I had a problem, so I would use Java. Now I have a problem factory. So if you run this again, how come there is no obfuscated Perl contest? Because everyone would win. So, and if you type pyjoke -- help, you can see you can specify some special categories like a neutral, Chuck jokes, jokes about Chuck Norris.
So
I've
your
never
5
tried
minutes
Python.
are off. So your lightning talk is ready to finish.
Okay, cut me off.
Cool. So I think Darren, have your screen back. Yes.
Yes.
Cool.
Okay.
I really like when we are in a online meetup and we have this feeling like we are in a real life conference, like the projector stop working or something like that. So
yeah, we are capturing the whole experience with this.
Yeah, cool. So you're back.
So, yeah, okay. So where was I? I was showing you some of these simpler patterns. So these two are a bit of a comparison. Let me jump on this a bit later. So if you use a single variable name, like x, as a pattern, and matches against a given subject, a variable can always generate any kind of value if you set it to the value that you're comparing against. So essentially, a variable like this always matches. And what it will do as extraction, it will extract the object that you're matching against. We'll see that there's a special case where you want to always match, because it's essentially a way of saying, I don't care what this value is. But you don't care about comparing the object. In that case, you can just use a single underscore, which is a special name, which again always matches, but it doesn't extract information because it means I don't care. It's what we call the wildcard. I showed you some constants at the beginning. There's just equality comparison. And if you have a constant like this one, it can work as an equality comparison. But there are some ambiguities that you have to be careful with, because if your constant is, for example, if you import the secant from OS as a global name and don't have the OS dot, this looks exactly like a variable name. So you'll end up in this case over here, and you don't want that to happen. So this matching requires that your constants has at least one dot in its name to work as this comparison. And other pattern, other simple pattern that you can have is this using a time name with the parentheses, and the parentheses are the key element here that make this a class pattern. And it's essentially checking that your object is an instance of a given class. So you'll see that these are relatively simple patterns. Simple patterns not necessarily meaning easy, but they don't have a lot of parts inside, of moving parts. So let's look at some complex patterns instead, which are composed with typically some other components or other patterns. So what you have in these top two examples look quite similar to the list unpacking that we did, and actually it's an extension of the list unpacking syntax. And the list unpacking is actually not necessarily restricted to lists, but any kind of sequence. And the same way that you can assign in Python using parentheses, brackets, or actually or just comma-separated values on the left-hand assignment. In patterns to assign sequences, you can either use parentheses or brackets or comma-separated values. Just notice that if you're using parentheses, you need a trailing comma, same as in a tuple. So the rules are similar to regular Python syntax. So if you have a pattern like this, and you can change this for square brackets, and its round brackets or square brackets are identical in this case. So this pattern will match if your object is a sequence, and it has 2 elements, because my pattern has 2 elements. And it also requires that every element inside the pattern matches the corresponding element within the list. So essentially, your patterns can be nested and have other patterns inside. So essentially, this 1, 2, 3 one is one of the constant patterns that I mentioned before. So that checks that, and this is matched against the first element of my object. So this is comparing the first element of my object with 123. And this pattern is matched against the second element of my object. And this will always match, so it doesn't add the condition, but it adds some information extraction over here. So this essentially will get the second element in this list, which is index 1, into A. And yes, someone is pointing me to a bug in this slide, so thank you about that. I'll get to it when I cover it, but thank you, Simon. So this other pattern essentially matches any list with at least 2 elements, and this star can be a sequence from 0 to infinite elements long. So this says that the first element must match this pattern, which checks that the value is an int. And this element, which is the last one, so it should be -1 here, as someone is correcting me, should also be an int because it has to match this pattern. And again, I need a sequence of these 2 elements. And this star mid will capture everything which is not the first and the last element inside this mid variable. So I'm doing a lot of things at the same time with very compact notation. And this, it's relatively to see how this generates lists would have an integer on both ends and anything in the middle. And that's exactly what this pattern matches. It matches lists that start with an int, end with an int, and have anything in the middle. So given that I use a variable name here, it will capture that middle part into a variable. You can also do something similar with mappings. This looks like a dictionary, but again, this works with any kind of mapping. And this essentially checks that the keys name and age are inside the dictionary that I'm matching against. So this is the condition for this pattern to match. And you see that this is slightly weaker. Dictionaries, and this is based on how dictionaries are normally used. In dictionaries, you normally don't care if the dictionary has additional keys. So I'm not checking that if object has a third key, which is favorite color. I don't care if it's there. The pattern will match anyway, as long as the mapping has a name and an age. And whatever is inside those respective keys will get matched inside these inner patterns. In this case, I use just variables. So I'm capturing N and A. But I could use an underscore if I just wanted to check that the key is present, but I don't care about extracting the value. Or I could say str parentheses parentheses if I want to check that the value is a string. Or I can even do nested things as deeply as I want. There are some minor restrictions about how you can nest and combine things, because some situations are impossible to decide or solve. For example, when generating a list, you normally can put two variables with star in the middle. But in patterns, you cannot add 2 things with the star because it will be impossible to decide where the first group starts and when the second one starts, because they can be, if you have 10 elements in the middle, they can be 5 and 5 or 0 and 10 or 2 and 8, and it's impossible to decide. So those ambiguous cases are not supported. And again, for simplicity of implementations, in in this kind of mapping patterns, the keys need to be something relatively fixed, like a literal or a constant or something like that. You cannot put arbitrary patterns on the key side. You can put arbitrary patterns on the value side. So this allows you to, essentially, what I'm looking here is what's the shape of this dictionary? Is this a dictionary with a name and age? This is the question I'm asking about the shape. Is this a list starting and ending with an int? Is this a pair starting one with 123? And at the same time, besides asking the question, I'm saying, okay, and if it is, what I want is this second number that I don't know what it is, I want to capture it to a variable, or I want to capture the middle values into a variable, or the corresponding values for these keys into variables. So let's look at some extra syntax, and when I say this extra syntax, these are some more fancy patterns that do not look like regular Python syntax, but allow us to provide some useful patterns. The first one is this vertical bar. Oh, really? My monitor tends to disconnect and reconnect, so I don't know what I'm sharing. Give me 1 second. It's almost like a projector.
Yeah. So I see a screen black. So it's like it's really disconnected from your computer.
Probably have a loose cable when I set up here.
Yeah, more Py jokes. We will have to do that if there is no other option.
Oh, that's great. My Chrome froze. So give me 1 second.
Yeah, that's okay. Let's just. Oh, it's back. Oh, but. Okay.
Yeah, Chrome is really unhappy about the change of monitors. So let's see how far I can get along without something else breaking.
Okay.
Not far, it seems. Okay, I'll be right back.
Okay. So we are waiting for Danny. He's having some problems with the laptop. Remember, if you want to join our Slack, you can use this link. You can also use the Py.Amsterdam with the QR. And something good to mention right now is, again, what I was saying before, that we have the, in our website is Py.Amsterdam. You have here. You can go there and there is a form. So if you want to propose, if you have a talk to propose, please use that form. And we really think that speakers are the most important part for the meetup. So if you want to participate, if you want to join, please do it. Welcome back, Danny.
Yeah, this is a collection of accidents. Oh, let's see.
That's okay.
All my cables are breaking down today. That's how you move to the computer. It's supposed to be mobile.
That's true. So
yeah, give me 1 second. I'm again and it's loading.
That's okay. That's okay.
My million tabs.
So Daniel is talking about structural pattern matching in case someone is joining just now, and we are having some technical issues, but that's okay. We're going to continue in a minute. Again, a reminder, we have a lightning talks. If you want to propose a lightning talk, you have to join our Slack. To join our Slack, you can go to Py.Amsterdam, or you can just use a link that I'm going to put here now in the screen, this one. So I'm turning your Danny. Cool. You're ready to go? Perfect. Thank you.
Thank you.
Good luck.
I seem to need it. So as I was telling you, this vertical bar essentially it can be read as or, one pattern on the other. You can separate multiple patterns with it. It matches is if any of the patterns match. So in this case, it matches if the object is either 200 or 404 or 500. So it should be roughly equivalent to this code. And then you have this as, this is called the as pattern. And it essentially allows you to use any pattern on the left, and it matches if the pattern on the left matches. But it also captures, if it matches, the whole thing into a variable. So this is a way where I can write, I want a list where the first element is a Boolean or the strings yes and no. And whatever it was, I want to capture it into the variable called flag. And you can see that I'm using star underscore, which means, and this list can have as many elements as you want. And I don't care about those, so I don't need to capture those. So this will check that the object is sequenced, that this length is actually bigger than 1. There's another bug in this slide. And the first element is either or yes or no. Type really quickly and it shows. And is a Boolean or yes or no. And it will capture as flag the first element, because this as flag ensures that the first element, that whatever is matching here, will also get captured into this variable. So you can convert any kind of pattern in a pattern that captures values, adding as and a variable name. And you can do a lot of combinations of this. For example, you can use this OR pattern to capture different variables. And this pattern is quite interesting because you see that it will always match, because the X on the right will always match anything. So if it tries these 3 different patterns, the third one will always be correct. And what it will do also, it will capture whatever value is needed. So this will always match, but it will still capture, let's say that I'm getting from some weird, very loose API, a value that can be either wrapped in a list or wrapped in a dictionary that has a value, or just a straight away value. So with this, I can essentially say, okay, if it comes, if I get a list with a single element, I'll get the value there. If I get a dictionary with the value key, I'll get the value there. And otherwise, I'll get the whole value. And I'll get one of these depending on the shape of my object. So people are telling me, with the first example, why doesn't extract obj equals this? And essentially, it's likely that you have the subset around, so you don't need to extract the whole thing. But when you have this additional pattern inside something else, like this pipe, you can use this as extra thing to match it. And this as can work with any pattern, not just with your patterns, but with anything, any pattern you can add as at the end as variable, and add an extra variable capture. So the last collection of patterns that you'll find are the class patterns. And class patterns are essentially an extension of what we see at the beginning, where we are changing a type, but you can essentially pattern match the value of certain specific attributes. So this essentially say, this object will match if it's DAC with the color of green, which is what it says here. And this one will match if it's a DAC with the color green and an H attribute. And by the way, I will want to attribute into A. And again, this could be a much more complicated pattern. So if I want to, for example, capture the H pattern, the H attribute only if it's an int, say int as A, and combine that and add some extra checking. And you can nest them as much as you want. So I want a DAG whose mum is also a DAG, and I want to extract the age of that mum. So you can see that with these very simple expressions, you can do things that would normally take you out of code to write the check, and also do the extraction of a variable that you're likely to need right away. So, something before we call this. So in this case, I'm using always keyword patterns to pick up the attributes. There's actually one of those magic Dunder protocol called Dunder match _args that you can define in your objects if you want them to support positional matching. And in this case, you define essentially which positions correspond to which attributes. And some of the built-ins and standard library classes will support this straight away on the release or on the alpha if you download it. For example, name tuples and data classes have the more or less obvious assignment of positional arguments to the positional name of the attributes. And if you look at this, something important to see when you see this pattern in the code is that this is not creating an object. This looks like an object creation, but again, the same as when we have the list on the equal side of an equal sign, and it doesn't create a list, actually. This is not creating a DAG. This is defining what kind of tags I want to capture. So let's put it all together and see how these patterns look inside our code. And to put all together, I need to show you what's called the match case statement. Or some people call it the match statement. Essentially, it's an overpowered if statement, which looks like this. You say match and the given subject, and this will be your obj in the examples above. And you can have several case blocks inside your match statement. Each case will have a pattern and a code block, and potentially a guard with an if label on the left. I will tell you in a second what this. These are essentially allow you to arbitrary Boolean expressions when you want to add more complex logic. And essentially, the goal of this code is to choose the right code block to execute, similar to an if statement. And at most, one block of code will be executed. So for a block to execute, the pattern must match the subject. The guard must be true. So the patterns are checked top to bottom. The pattern one is checked first. If it matches, this code runs, and that's all of it. If it fails, this pattern is matched. Let's say if match, then the guard is checked. And if both are successful, the code runs. If any is unsuccessful, you go to the third pattern, and so on and so on. If you fall back through the bottom, this code does nothing. It's like an if statement where the condition is false. So when the pattern is matched, the variables that are trying to capture are also assigned. So you can use these variables inside the guard to check complicated things. You can also, of course, use the variables that are matched inside the code block, and that's typically when you need to use them. So let's write a real example of this. Let's write what's called, I call this function my slicer. And I want a funky API, which is somewhat similar to the range function in Python, where I essentially am setting a start, stop, and step arguments, but I want the start and step arguments to be optional. So if I pass only a single argument, this is supposed to be the end of a slice that I'm taking. And if I pass both, I'm taking both. And if I pass 3, I'm taking a slice like this. So this is a simple wrapper to extracting a slice from a sequence. And the only thing weird is about how I'm taking these arguments, which is identical to what the range built-in function does. So if I try to write this with my first idea, I say, okay, I'll make the start and step arguments optional. And this breaks because I cannot put an argument, a mandatory argument after an optional argument in Python, and this will give you a syntax error. So at this point, I say, oh, okay, so what I need to do is take an arbitrary number of arguments or allow the false or null and do a lot of checking on this argument to see what they are. So this seems like a perfect job for pattern matching. So our slicer takes star args, and I'll match these arguments that I got, and I want to know what is the shape of these args. Is it just a stop value? Then I return this. Is it a start and stop value? Then I return this. And is it a triple of these values? Then I return this. And also I can say case underscores. This will always match if none of the above matched. I say, okay, then there was something wrong with the arguments, and I raise a type error. So this is very clean, straightforward. And if we look at the spec, which I've shown in the previous slide with these arrow keys, and this was like our abstract spec, you'll see that our code looks essentially the same that our spec. I just changing the arrow keys with return. But other than that, this is essentially typing our pseudocode inside Python, which is a nice thing and the part that we like about Python. So I'll go through some other quick examples. I don't know how we are on time, so I don't want to overrun, given our delays. So with no coding sample is complete if you don't do fizbus. So that's the problem where you have to print numbers 1 to 100, but replace multiples of 3 with fizz, multiples of 5 with bus, and multiple of both with fizbus. So I essentially can loop on the numbers from 1 to 100. And essentially, if you look at this seems to match over two things. This is actually matching on a tuple, but it's perfectly valid syntax in Python. So the two things that I'm matching are the divisibility by 3 and divisibility by 5. And if it's divisible by both, I print fizbus. If it's divisible by only 3, and I don't care about this one, so I can use underscore, I'll use fizz. If it's divisible by 5, I write bus, and in any other case, I'll print type. Note that I can start using this don't care rather than being explicit at the bottom, because I'm sorting my cases from more specific to more general, and that's the way you normally should do it. So the specific cases match first because they're on the top. And if then you have some files that capture more general scenarios. And as you can see, you can say that match supports actually matching on multiple objects. That's not actually true. It's a tuple, but you can use it as matching on multiple objects, and it works the way you imagine it would, which is quite nice and useful in many cases. So Alexander is asking me, looking at the slicer example, it's a great question, so I'll stop for it. Slicer example of pseudocode, what's the reason behind not super syntax where overloading function signatures are used for pattern matching, like in the pseudocode? And that actually would be great. That sounds like a cool idea. It was something I could tell you about how this feature was designed is that the way we built it, it was already a big change and quite controversial. So we tried to do the minimal thing that makes sense and is useful. You can always add more features like the way you're mentioning later on. But this is a way of getting something that works and getting the community to try it and run it. So it's possible that in the future, one might find how to put this into function definitions. And actually, Tobias, which is one of the authors, says that pattern matching is actually a way of writing function definitions, and everything else is like a secret special case of that, and it's a way to view it that's interesting. But still, putting it in function definitions is complicated because function definition is one of the most complex parts of Python syntax, and there are a lot of things that you can break around there. So for a matter of being conservative with the change, it wasn't done on the first iteration. Maybe done in the future, or it may be never done because you have to figure out how to create a syntax that integrates properly with the existing syntax. So thank you. I love that question. Thank you, Alexander. So this was our first example. Again, this is a very common example. You get a JSON object from an API, and you want to check if it's you have different shapes of JSON to represent different things or different scenarios that you want to cover. Let's say I'm making a login screen, so I get the user info. And if the user doesn't exist, it's an error. And I want to greet the user on his or her birthday. And I then, if I get the user, and the user is a nested object with the date of birth, which is D, and D is a birthday, then this should probably have some complex logic that removing the year and checking today's date. So here you can see a guard where I can add more complicated conditions. The nation page that says happy day, and otherwise rare welcome page. And if I have something which doesn't look like an error or a user, there's something very wrong with the API and I'll raise an exception. So I will answer Daniel's question later because I want to cover some more stuff. So the other way you can do this is, let's say, okay, a lot of people have wanted a switch statement for a very long time in Python. There were a few rejected PEPs. We finally have it. So match is our thermonuclear switch statement because it does so many more things than switch. But it can also do some of the switch basics, like matching with specific values. And you can insert in the middle. If I get status quo between 500 and 699, just adding an if condition, I can raise a server error and otherwise not do this. In this case, where you're essentially not using the capture feature and just matching like this, I would say that you're trying to write an if statement using the match syntax. So you may decide that it's not worth it to use the match statement for this. And the if statement is a perfectly good statement. Python developers have been using it for decades, and 95% of them have answered to surveys saying that they are very happy with how the if statement works. So it's still a good choice. Consider using it if match isn't adding anything new. So there are some other use cases that may be around. If you see PEPs 636, you can see example of simple parsers, not like full-fledged parsers, but things like more like a command line interface or argument parsing or things like that. And to walk through recursive structures, I have a very complicated example here that you can take a look at. I'll share the slides later on, so you can look at this example. And this is the implementation of red black tree. And red black tree is a complicated algorithm where if certain pieces of your tree look in a certain shape with certain colors, nodes have color. If there's a black node on top of a red node and the ankle of the red node is also black and conditions like that, you have to switch this around. And I converted the regular algorithm from an algorithms book, the CLRS, classical CLRS Introduction to Algorithms, into pattern matching, and it's so much cleaner and so much easier to read which are the patterns that you're looking at. So for essentially identifying shapes inside recursive structures, particularly trees that other recursive like linked lists or things like that, I think it was right. So I'll stop here to answer a few questions. I don't have much more anyway. So people asking me, why is there no else clause in the case statement? And that's a great question, and we've struggled with this for quite a bit. There are a couple of reasons. The first one is that case underscore works, and we can always add else later if we want. So we didn't need it right away. And again, we try to keep the design minimalist. Every time people wanted to add an else clause, there was a weird confusion. Some people wanted to add it like at this level next to the other case statement, because the code that you're doing here is comparable to the code at this level. Some of you say, no, the else should go on the left. aligned to the match statement, same as an if-else statement, because all those statements have the else at the same level of the main part. So there was a 50-50 split, and it was easier to not add it because we actually didn't need it, than to get all those people to agree with each other. So thank you for the question, Daniel. So someone's asking me, is there a way of calling the match function as a function within without using the match case syntax? I can see this being useful inside building logic apps. The only way to use patterns right now is in the match statement at this point. Possibly in the future, it can change. So there are some philosophical points that I want to cover very, very quickly. Most of the idea of pattern matching comes from functional programming, and Python is a very object-oriented programming. So, but it has a lot of functional programming elements. So it's interesting to see how they fit each other, and it allows you to follow a somewhat different programming paradigm. So in functional programming and with pattern matching, you have essentially dumb values and smart functions. Essentially, the value doesn't know the logic to do one thing or the other, and the logic is outside in your functions. So your functions are probably built with match statements to recognize the different kind of objects. And that allows you to decouple the object representation with the possible variance, which there are some scenarios where you have this very limited set of actions, and you want to be able to add different, let's say, verbs and nouns. So you have a limited set of verbs, and you want to be able to add nouns to your system. And that's very easy in the OOP paradigm, where you just add subclasses that implement the same methods, which are the verbs. So the classes are the nouns, and the methods are the verbs. When you have a relatively fixed number of nouns, but you want to add a lot of different verbs, for example, in trees, you have either nodes or leaves, and those are or two different options. But you want to do a lot of different operations on trees. Normally, you want to put your functionality outside the object, because otherwise you end up with an object with infinite methods, the class with infinite methods. So for that scenario, the dumb value and smart function makes a lot more sense. So it's the dual to method dispatch. In method dispatch, you decide based on an object which method to call. The type decides. In this case, the pattern decides what to call, and it's outside of the object. And it's somewhat comparable in object-oriented programming. If you want to do this, you can do the visitor pattern, but it's quite cumbersome. You have to define an auxiliary class and a lot of auxiliary methods. And this provides some of the benefits of the visitor pattern with a much less boilerplate and a cleaner syntax. So yes, I recommend you to look at the 3 PEPs, which have different purposes. In this repo from Guido, he has added some code examples of different applications, which are quite interesting. There's an expression evaluator with a parser, which is quite nice, and an expression simplifier. These examples, some of them were written for the first version of the PEP, so maybe slightly outdated, but take a look at those if you like. And that's all I had for today. Thank you for the patience through the breakdowns. So any...
Let's do some
clapping.
Thank you, Darny. That was super interesting. I really like personally really like this new feature. I think it's super interesting. So I would say let's use just I don't know. Maybe we can reply only one more question, because you're already...
Yes, I've already been answering some of those. So
so let's. There is some delay, so I will give time. So our next speaker is Juhis. He's already here, so I can probably bring him to the stage. I'm going to turn off your camera here. Hello, Juhis. Welcome.
Thank you.
Hello.
Welcome. Thank you for being presented in Python Amsterdam. So I want to repeat what I said earlier, that you can join our Slack using this bit.ly URI. If you want to propose a lightning talk, you can reply to a message that is there. I'm going to give that, to that person the data to join the streaming. Also, please send us some messages on Slack or in the chat to see how is the quality of the audio streaming, etc. Because it's the first time for us using a different platform. I'm watching that in the TV next to me, and it looks super good. But it's also good to have some feedback from the rest. So I don't see questions. So you have someone saying it was good. Cheers, Martin. So yeah, thank you very much, Danny. That was super good.
Thank you very much for the audience. And yes, you can reach me at Moisset at Twitter if you like, and ask more questions if you. I love to discuss about this, so feel free to reach out.
Yeah, cool. Yeah, the Daniel Twitter is this one that you're seeing now in the screen. Okay, so thank you very much. I hope it's not the last time we have you in our meetup, and I hope next time is here in Amsterdam and we can share some drinks and chat. Cool. So now we're going to our next speaker. That's you're joining from Finland, right?
Yeah.
Cool. So how is the weather? Because here in the Netherlands, you can guess how it is, right? It's raining and it's windy.
It's been super beautiful lately. Really cold, like 15 to 20 degrees on the negative side. But it's been really beautiful. Like sunshine all day long. It's some of the best days of the year, at least the winter. Really hoping that one day I will also get to Amsterdam and join the rain with you.
Yeah, please do. We have some sun sometimes. That's yeah, I'm looking forward. We should organize a meetup with all the participants that were joining our online version during the last year. You know, I don't know, Jan, if you remember, but I think our first online meetup was around this date a year ago. So maybe the 25 of March.
Let me have a look.
The website. So it's a real full year. Okay, so I think we should leave the stage to. We can reply that answer in the chat, and we can give the stage to Yuhis. And yeah, thank you. It's all yours.
Awesome. Thanks for having me. It's super nice to be back. I think my first Py.Amsterdam visit was exactly a year ago. I think it was sometime at March. Maybe the first or the second meetup. Thanks, Daniel, for the great talk. Pattern matching is something that I'm super excited about. I think it's probably the feature that I'm most excited about in Python 3. no changes to the team. Nobody has joined and nobody has left. And obviously I cannot see your hands, but from my experience doing this talk, there's not a lot of people who keep their hands up. We work on an industry that is ever changing. Things go fast. The tenure of a developer in a company is rather short. On many places, on average, it's way less than 2 years. So this means that there's a lot of knowledge, a lot of decisions and motivations that are lost in time. Because one of the best things that documentation can do, and what I would say that it should do, is to provide context for the changes that we make. It's not just the documentation of what happens, but especially why it happens. And this applies to any type of documentation. Whether it's your README file or code comments, you should talk about the things that are not kind of reducible from the code. Good code can tell us what it does, but it can never tell us why it does what it does. So for most of the documentation that we use day to day, we want it to be a living organism. It needs to be updated regularly. Nobody wants to see the README or API docs or code comments that are out of date and incorrect. But if we keep everything up to date, we lose a lot of history. And my idea of contemporary documentation is to add a little bit, not a lot, but a little bit to our daily habits, to capture the moment in history and keep it that way. And if we think about what kind of things keep the history intact in our day-to-day, we talk about commit messages on the version control, we talk about the code review, and we talk about stories and tasks. Whatever tools you use for this is irrelevant. I am mostly using terminology from using Git and GitHub and Jira tickets, but you can mentally replace them with the tools that you are using. And the idea here is that I don't want you to take a bunch of new tools, because by the time you go back to work tomorrow, you've already forgotten them. I want to give you some ideas that you can implement tomorrow with just a small percentage change that over time accumulates into a great history of documentation that can really help your team, especially in the future, to figure It's one of those things that I could talk for an hour about why I love code reviews. But they are a really good place for learning, for documenting things. So let's talk about a couple of things when it comes to documenting the moment in history. So the first and most important thing is, regardless of how you perform the code review, write the things down. Sometimes I like to do a code review sitting down with a colleague, kind of pair programming style. Sometimes it's asynchronous, done on GitHub pull requests. Or it might be patch notes on email. Whatever it is, write everything down. Because in 2 years, you're not gonna remember them. And you might not be there anymore. Ask a lot of questions. I was talking to some students yesterday about code reviews. And the key thing I told them is, code review is not a judgment process. It's not a process of a senior developer telling somebody what they did wrong. It's an opportunity for the entire team to learn about the code base, to discuss the changes, and to stay up to date what's happening with the code base. Once the code is committed, it's shared code with the team. Nobody owns it anymore, individually. So, ask a lot of questions. If there's something you don't understand, how it works, or why it's done like that, ask it. And write the question and the comment, the answer, down somewhere. And when things are resolved or answered, don't delete the comments. Tools like GitHub has a really nice functionality that you can resolve discussions. So it hides them from the pull request, so you can focus on the things that haven't been fixed. But if you go back to them, you can still find all of them. Keep the history intact. It's not just a temporary discussion. It's contemporary, and it should stay in the history of the project. And then the third part is the stories, tasks, bug reports, tickets, whatever you use and however you call them. This is one of the places where I see most opportunities for improvement. And one of the key things to document here is the origin and the business driver of these changes, or the need for the change. Because like I mentioned earlier, it's really scary to delete or change code, because you don't know if it's needed anymore. If a project has a lifetime of, let's say, 10 years, there's gonna be things that are gonna be kind of become unnecessary. But if we don't record the original need and the business reason, it's gonna be impossible to know. And then, just for the sake of safety, we keep everything in the code base. For any kind of bug, I recommend like steps for how to reproduce. That also helps in the future if something similar comes up later. It helps to figure out if this is the same thing that somehow reappeared, or if it's a new thing. And related to that, the definition of done. What are the boundaries of this change? And these three things together form a really good basis. But this is just the starting point. And once again, ask questions. Quite often the things are written on the issue tracker or task board, at least partly by the business people or the customer support. And they might not know what to write. They might not know, they might not be on the same kind of wavelength really good way to capture all the things that we will forget. The why and the motivation. And also the decisions. What did you consider? It's also important to write down things that you decided not to do. Things that you tried but didn't work. Because that's gonna save a lot of time. When, later down the line, somebody asks you, why wasn't it done this way? And then you might be like, well, I don't know. I can't remember if we even discussed it. So I want to show a really quick workflow of how these things come together using Git and GitHub and GitHub issues. Since most of the code that I work in Teams is under NDA, this is kind of a mock example. Don't pay too much attention on the code. It's total nonsense. So let's say that you come to a project or you see this code on your Python. You see some kind of a sum function that takes a couple of numbers. And then there's something that rings a bell to you, like, this doesn't look like the sum that I'm used to. What was taught to me at school is A plus B. But now I see something completely different. There's probably a good reason. I trusted the developer who did it a couple of years ago, had a good reason. But they're gone. So what do I do? First I can use git blame. I can use it on command line. A lot of editors and IDEs have this built in, or with an extension. And I can find the commit that introduced this line of code. I can copy the hash of the commit. I can go to GitHub into the repository and I can search for that hash. And it gives me a commit that says what the name the commit message headline is. I can click that and I will end up to see the changes and also the commit message. So we have some explanation here, but circled in red, you can also see from which pull request did this commit come from. So I can start from the commit message and then I can go into the pull request. And since this is just the mock example, I don't have a review, I don't have comments, but at this point you could see what was discussed a couple of years ago. This change was done in 2019, and now, 2021, coming back to it, I could see what was happening, what was the motivation, what kind of discussion did the team have about this change. And since in this case I'm using GitHub issues, in the pull request, I can say which tickets does it fix or close. And I can click to them, and I can see the business reason. And I can see the discussion about the origins of this change. So for example, in this case, I would be able to then see that these aliens are no longer served by the company. So we don't actually need this anymore. And it's safe to change if we need to change it. And this is the way I often work. If I get a bug report, if I need to start fixing something, this is the workflow that I start from. I always look at the couple of last commits or pull requests just to get a good idea of why things happened in this context, in this part of the code. What were the reasons? Sometimes you can find kind of why the bug happened by just looking at the pull request and figuring out that, hey, this corner case wasn't even discussed. find me on Twitter at Juha-Matti. I will post the slides on Twitter after this. I will also share them in Py.Amsterdam Slack. You can find more about me on my website. I write a weekly blog about technology and communities. And if you want to get in touch after the event, you can use Twitter or reach me out via an email. And I also run a monthly developer newsletter called Dev Breakfast. If you want to get some interesting articles curated by my colleagues every last Friday of the month, fresh to your inbox, while you enjoy the morning breakfast. Thanks. And I think there's been a couple of comments on YouTube. So the first one comes from Marc-André, who says that unfortunately tools like GitHub nudge developers into one-line commit messages. And yeah, I think there's a lot of kind of recommendations and ways of working that indeed does that. It like a lot of guides and tutorials about using Git say that hey, you can do full Git message, commit message with git-m or git commit-m. And it took me a long time to kind of change my habits. Then we have a comment about Quit Squash. So they returned to the project after 2 years, found out 80% of the commit messages are gone. Yeah, I'm not a big fan of that either. So when you have kind of work in progress commits, squashing them before the code review, that's a great idea. But basically removing the history once you have good commits, not a big fan. And Alexander comments that he also, the fear of deleting code, that's something we all have to live with. Making it easier for other people, the future you, the future teammates, and future people working on the code base. And then, yeah, there's a couple of reasons why it's scary. One is that if you don't have tests, you don't know what breaks. But also, even if it's not something that breaks the code, but you don't know if it's needed. I'm a big proponent of deleting all the code that is unnecessary. Like, the less code we have, less problems we have.
Thank you, Juhis. That was a really nice talk. Sorry, I think I was offline for a minute. I had a problem with my Chrome. So yeah, thank you very much. I think we have some time for questions. If there is more questions, I don't know if anyone. There is some delay, so with the
we can wait for a moment.
Yeah, let's do that.
And also, if something comes up later, I will be in the Py.Amsterdam Slack, so feel free to comment there, and we can have good discussions about best practices. Like all the things, all the ideas that we present in these meetups are just that they are one view of things and ideas, and I'm super happy to also hear kind of conflicting ideas and different ways that all of you have found out the good ways to do these kind of things in your teams.
Cool. So thank you very much. I'm going to turn your screen share off. I was losing Jan, so I don't see Jan in the video. So something wrong is happening with our system. But I want to say thank you, everyone. Thank you, Juhis. I think it was super nice. So we have some people saying thanks, sending some thanks in the chat. I don't have anyone, so that's bad news, because I think it's going to be the first time that we don't have lightning talks. So yeah, I hope next time we have some we have someone proposing that, and we can be back to having the best part of our meetup. So
I can say from experience that lightning talks are super fun to do. It's the easiest way to get started with meetup talks and conferences. At least for me, it's one of the best moments of any conference when we get to do lightning talks.
Yeah, that's true. And I think you were giving a lightning talk like a year ago here, and now you're a speaker. So thank you very much. That's super nice to have. Cool. So Jan is back. I think we are ready to say goodbye. I want to say thank you to everyone that was following us on YouTube. Remember, you can join using this QR that you have here. You can join our Slack and keep the discussion going. And yeah, so I hope we can see each other in Amsterdam soon. I don't know, Jan, if you want to say anything else.
No, I just wanted to say thank you to everybody for joining in tonight. We had quite many people, so I hope you enjoyed this. And don't forget to go to Py.Amsterdam and submit your ideas for your talks. And if you don't like our website, you are welcome to help us update it. So you can go to our GitHub repository and submit your pull request.
Yeah, and remember, you can go to Py.Amsterdam and you can submit a talk if you want to be here presenting in our meetup. Speakers are the most important ingredient for the meetup, so please do it. Yeah, see you everyone next time. Thank you very much. Have a really nice evening. Cheers.
Bye.
Bye.